Yeah, hi everyone. Be happy to live in a 5G world. And we have radios and scientists. Harvesting energy from the air. Metal surface based antenna turns ambient radio waves into electric power. March 6th, year 2022. Technology could make it possible to use radio emissions from cell phone networks to wirelessly power sensors and LEDs. Yeah. Researchers have developed a new metal surface-based antenna that represents an important step toward making it practical to harvest energy from radio waves, such as the ones used in cell phone networks or Bluetooth connections. This technology could potentially provide wireless power to sensors, LEDs, and other simple devices with low energy requirements. By eliminating wire connections and batteries, these antennas could help reduce costs, improve reliability, and make some electrical systems more efficient, said research team leader Xiangfeng Zhu from the University of South Florida. This would be useful for powering smartphone sensors such as those used for temperature, lighting, and motion, or sensors used to monitor the structure of buildings or bridges where replacing a battery might be difficult or impossible. In the journal Optical Materials Express, the researchers report that lab tests of their new antenna show that it can harvest 100 microwatts of power, enough to power simple devices from low power radio waves. This was possible because the metamaterial used to make the antenna exhibits perfect absorption of radio waves and was designed to work with low intensities. What a coincidence. Although more work is needed to miniaturize the antenna, our device crosses a key threshold of 100 microwatts of harvested power with high efficiency using ambient power levels found in the real world, said Clayton Fowler, the team member who fabricated the sample and performed the measurements. The technology could also be adapted so that radio wave source could be provided to power or charge devices around the room. Harvesting energy from the air. Scientists have been trying to capture energy from radio waves for quite some time, but it has been difficult to obtain enough energy to be useful. This is changing thanks to the development of metamaterials to the ever-growing number of ambient sources of radio frequency energy available, such as cell phone networks, Wi-Fi, GPS, Bluetooth signals, and solar storms. With the huge explosion in radio wave-based technology, there will be a lot of waste electromagnetic emissions that could be collected, said Zhu. This, combined with advancements in metamaterials, has created a ripe environment for new devices applications that could benefit from collecting this waste energy and putting it to use. Metamaterials use small, carefully designed structure to interact with light and radio waves in ways that naturally occurring materials do not. To make the energy harvesting antenna, the researchers used a metamaterial designed for high absorption of radio waves that allows a higher voltage to flow across the device's diode. This improved its efficiency at turning radio waves into power, particularly at low intensity. Testing with ambient power levels. For lab tests of the device, which measured 16 centimeters by 16 centimeters, the researchers measured the amount of power harvested by changing the power and frequency of a radio source between 0.7 and 2.0 gigahertz. They demonstrated the ability to harvest 100 microwatts of power from radio waves with an intensity of just 0.4 microwatts per centimeter squared, approximately the level of intensity of the radio waves 100 meters from a cell phone tower. We also placed a cell phone very close to the antenna during a phone call, and it captured enough energy to power a LED during the call, said Zhu. Although it would be more practical to harvest energy from cell phone towers, this demonstrated the power capturing abilities of the antenna and also the emissions from the towers. Because the current version of the antenna is much larger than most of the devices it would potentially power, the researchers are working to make it smaller. They also They would also like to make a version that could collect energy from multiple types of radio waves simultaneously so that more energy could be gathered. Check this out. That's obviously a video I made some time ago, but let's have a look.
We pulled the stored coil out and set it up here as the receiving coil, and the other coil we set up as the transmitting coil. And both these coils are tuned to the same frequency. And instead of a clip lead, we gave the receiving coil 800 watts worth of light bulbs as a test load. Now I thought 800 watts would be more than enough, but the receiving coil could actually drive these way beyond 800 watts if the transmitting coil got any closer than 5 meters. This made no sense to me at all, since the electric coupling between these two coils is so incredibly small. It measured about 10 femtofarads, which is 1/100th of a millionth of a farad. But later I ran some detailed circuit simulations, which confirmed that even this amazingly small amount of coupling can pass dangerous amounts of power between two well-tuned Tesla coils, all through the magic of resonance. After this discovery, a friend, Mike Kinnon, felt rather strongly that light bulbs were a terrible choice for a test load. He thought this effect should be used to push his lazy butt around. So he built the world's first real Tesla Roadster. There's an aerial up here, and this aerial consists of a bunch of welding rods that form a disc shape, and that establishes an area where it can collect electric field lines that ultimately come from the transmitting coil. That energy goes down here to a little resonant transformer mounted on the frame. And this transformer can be quite small because the operating frequency is so high. The transformer steps down the voltage to about 200 volts or so and runs this 180 volt gear motor over here. And then the gear motor is just linked to the drive axle under the seat. That's all it is. Here's a short video clip of the Tesla Roadster in action at a maker fair a while back. Note that Mike is wearing heavy welding gloves. He kept complaining about getting shocks from holding the steering grips. It's too bad we didn't collect the energy from him as well. Oh, when the cart starts moving, you can see some lively sparking down here from the grounding chain that drags behind the Roadster.
Yeah, so it's somehow really interesting. First, we have a C-pinch device, and now they are harvesting energy from the air, like it would be something new. Really interesting. I just wanted to share that because somehow it seems that there's this kind of revelation going on in science. I don't know. Hopefully, it would be really cool. Science could spend all the money much better, I guess. Yeah, let's hope for it. Thanks. Bye.